Hello, I'm Suraj, and today I'll be comparing two types of spectroscopy, mass spectroscopy and photoelectron spectroscopy, to decide which one's better for our work in biochemical research. So, how is the data collected? Mass spectroscopy uses high energy source like a beam of electrons or laser to knock electrons off the molecule in the sample. That turns them into charged particles called ions. Then, a magnetic or electrical field is used to separate those ions based on their mass-to-charge ratio, basically how heavy they are compared to their charge. The result is a spectrum that shows peaks for different masses, and we can use that to figure out what's in the sample. Photoelectron spectroscopy, or PES, works differently. Instead of measuring ions, it shoots high-energy light, like ultraviolet or X-ray photons, at the sample. This causes electrons to be ejected from the atoms or molecule. The machine then measures the kinetic energy of those electrons. Since we know the energy of the incoming light, we can subtract and find out how tightly the electron is held, its binding energy. So, both techniques involve adding energy to the sample, and both require it to be in gas form. But the difference is that mass spectroscopy measures the mass of the particles, while photoelectron spectroscopy measures out the energy. Now, let's talk about how each technique helps us look at atomic structure. Mass spectroscopy is all about identifying what's in a sample. It gives us information about the atoms and molecules by breaking them apart and measuring the mass of each fragment. From that, we can figure out the molecular formula and sometimes even predict how the molecule is structured. Photoelectron spectroscopy takes a more detailed look at the electron structure. It shows us how electrons are arranged in atoms, which shells they're in, how tightly they're held, and how the energy levels are spaced. This helps us understand chemical bonding and even compare elements or compounds based on their electron configuration. So, mass spectroscopy is more physical. It tells us what's there and how it's put together. Photoelectron spectroscopy is more electronic. It tells us how electrons behave and where they're located. So, what information did we get? Mass spectroscopy gave us the molecular formula of a compound, isotope ratios, structural information, and overall, they're super useful for figuring out unknown substances or analyzing mixtures. It's already used a lot in the pharmaceutical industry to study many different things. Photoelectron spectroscopy gave the binding energy of the electrons and information on orbitals and energy levels, as well as details about chemical bonding and valence electrons. This is really helpful if you're studying how atoms bond or looking at electron behavior in a very detailed way, but again, mostly for small molecules or elements. As for limitations, both methods definitely have some limitations. Mass spectroscopy requires the sample to be ionized. That works fine for most things, but some larger molecules might break apart in a way that makes the data confusing. Also, if the molecule doesn't ionize well, the machine can't detect it properly. Photoelectron spectroscopy needs the sample to be in gas form or at least vaporizable. That rules out a lot of the biological molecules like proteins and enzymes, unless they're specially prepared, which is hard to do. Also, photoelectron spectroscopy instruments are expensive and require vacuum systems and high-energy photon sources, which makes it a lot harder to use regularly. So while both are powerful, each one is better suited for different types of samples. As for the final recommendation, I think mass spectroscopy is a better choice for our research. It's already widely used in the pharmaceutical industry and is great for identifying unknown compounds, analyzing biological substances, and tracking things like drug breakdown and metabolite levels. It works well with complex mixtures and larger molecules, which is exactly what you deal with in drug development and biochemical testing. It's more flexible and more directly useful for our kind of work. Photoelectron spectroscopy is definitely interesting, especially if you're studying atomic structure or doing basic chemical research, but for practical everyday use in studying samples, it isn't as useful. And here are some of my sources.